In this video, we're going to discuss the topic of present value. At the end of it, you should be able to value any cash flow stream, though it may take you a long time to do it. Whether it's stocks or bonds or a project or anything, I don't care what type of company it is. I don't care why the cash flows are being generated. I just want to know what the cash flows are. We're going to walk away with 3 things to look for and a mathematical equation to use. Okay, so the way I want to approach this is look at these 4 different magic money machines, and they're going to produce cash flows as described here, and I want to ask you some questions about them. Answers to those questions will give us the rules that we need. So here's today, time 0, and then time 1 a year from now. I always draw a timeline so you can see what's going on. This magic money machine, and you trust me completely in this, is going to pay $1,000 exactly a year from now. My question is, how much are you willing to pay me today to buy this money machine that will print $1,000 in exactly 1 year? Let's just say you answered $909.09. Okay, so let's look at money machine B. I don't care if that's what you really would pay me, just assume that it is. Money machine B is going to pay you in 1 year $2,000. Alright, so the question is, would you pay me more or less than $909? In this case, you would pay me more, right? Because clearly you would rather have more money than less money. Alright, the next one, money machine C, is going to pay $1,000, but it's not going to pay it in 1 year. It's going to pay that in 2 years. So which one would you rather have, machine A or machine C? You would rather have the money come in a year rather than 2 years, so you're going to pay less than $909 for this one. Okay, finally, money machine D. It's going to pay you in 1 year, but I'm not sure exactly what it's going to pay. 1 year from today, it's going to flip a coin. If that coin comes out to be heads, you're a winner, you get $2,000. If it comes out to be tails, you're a loser, you get $0. Most people would say they're willing to pay less than $909. They would rather have the money for sure. So let's go over those again, because this is really important. Would you rather have $1,000 in a year or $2,000 in a year? Clearly you'd rather have $2,000 in a year, so size of the cash flows matters. Would you rather have $1,000 in 1 year or $1,000 in 2 years? You'd rather have it sooner or later, so clearly timing of the cash flows is going to matter. Would you rather have $1,000 guaranteed, or, and think that on average you're going to get $1,000 when flipping the coin? Would you rather have the risk or the sure thing? Most people are going to say the sure thing, so risk of the cash flows are going to matter. So everything we do for the rest of the course, when we're trying to value anything in real life, when you're trying to value anything, you need to know the size, timing, and risk of the cash flows. Okay, so now let's try to develop a mathematical equation where we can use that concept of size, timing, and risk. Alright, let's say here's today, and in 1 year you're going to get $1,000. Now let's say your interest rate is 10%. If that's the case, how much are you willing to pay me today to get those cash flows? Here's what I want you to think about. If you watch the future value equation first, the future value video first, you'll know the equation. The value in year 1 is equal to the value today times 1 plus r to the 1. So the value today is equal to the value in year 1 divided by 1 plus r to the first. So this $1,000 is actually worth today $1,000 divided by 1.10, which is $909.09. Now let me write that a slightly longer way here. I'm going to do 3 cash flows. 3 periods. Here's time 1, time 0. Here's time 1. Here's time 2. Here's time 3. Let's say you know you're going to have $1,000 in the bank at year 3. Your interest rate is 10%. If the bank will have if your account will have $1,000 at year 3, how much will it have in year 2? We'll have 1,000 divided by 1.1, which is equal to $909.09. If your bank account has 90909, let's say the right number of 09s there, in year 2, how much will it have in year 1? $909.09 divided by 1.1, which is $826.45. If you have $826.45 in the account in year 1, how much do you have in there today? $826.45 divided by 1.10, which is $751.31. So what happens when, and to me it's easier to see the money going forward. So I have the $751.31, multiply that times 1.1, you get $826.45. When you take that $826.45, multiply by 1.1, you get $909.09, multiply that by 1.1, you get 1,000. So the rule is this: the value today is equal to the value at some point in the future in year n divided by 1 plus r to the n power. Some people write it like this: the present value is equal to the future value divided by 1 plus r to the n. So anytime I'm moving backwards in the timeline, then I need to divide. Alright, the terminology present value and future value can be a little confusing, and I want to show you why by doing the following. So what we've done so far is we had some cash flow in the future, and let's say we're going to have year 4, 5, 6, and 7, and I say, look, $1,000, this is today. So you get $1,000 in year 7, how much is it worth today? I mean, that's kind of the questions we've been prepared to answer. What I want you to be able to answer now is, what if the question said, what is the value in year 4? So I tell you something like this: you're going to make a deposit into an account 4 years from today, and at year 7 you need to have $1,000 in that account, and your interest rate is 10%. How do you do that? Well, you know, present value in this case doesn't really mean present value is the value today. You know, the value in year 4 is equal to the value in year 7 divided by 1 plus r to the what? Well, I go back 1, 2, 3 steps. So that would be to the third. So this would be $1,000 divided by 1.10 to the third, which is equal to 751.31. What can be confusing is if I say present value is equal to future value divided by 1 plus r to the n. In this case, I'll say the future value is 1,000, 1.10, and I want to know the value in year 4. That goes back 1, 2, 3. So that's 751.31. So see, what I'm trying to say here is that present value just means some period, some time before the payment is made. I don't know if that's, don't take that as literally today. So this is why I prefer this type of notation rather than this type of notation. But again, present value is not necessarily the value today. It's just some value before the future value. When does future value occur? Sometime after present value. So that's why it's important to draw the timeline out. See exactly when the cash flows occur. See exactly what the question is asking for, the value in what year. So if it asks you, just to give another example, last thing here, if I want to know the value in year 2 of the cash flow that occurs in year 7, I divide by, and interest rate's 10%, that's divide by 1.1 to the 5th. Right now I can do this at any year. The value in any year is equal to the value in some future year. The value in any year, n, is equal to the value in some future year, year n plus k, divided by 1 plus r to the k. So if you're more mathematical, that's the pure correct way to write it. V subscript n plus k divided by 1 plus r to the k. Work through the problems, watch the videos with the examples, and I think it'll be pretty clear.